Physics Part 382. Beta particles. Beta particles are fast moving electrons. Beta particles have speeds in excess of 99% of the speed of light. These particles have half the charge and very much less mass than alpha particles. Consequently, they are much less efficient than alpha particles in producing ion pairs. They are thus far more penetrating than alpha particles, being able to travel up to about a meter in air. They can penetrate cards, sheets of aluminium up to a few millimeters thick. Their charge means that they are affected by electric and magnetic fields. However, there are important differences between the behaviors of alpha particles and beta particles in these fields. Beta particles carry a negative charge and are thus deflected in the opposite direction of the positively charged alpha particles. Because the mass because the mass of a beta particle is much less than that of an alpha particle, the beta particles experience a much larger deflection when moving at the same speed as an alpha particle. It was stated in the previous section that the nucleus contains protons and neutrons. What then is the origin of beta particles emission? The beta particles certainly come from the nucleus, not from the electrons outside the nucleus. What happens is that just prior to beta emission, a neutron in the nucleus forms a proton and electron in order to change the ratio of the protons to neutrons in the nucleus. This makes the daughter nucleus more stable. In fact, free neutrons are known to decay like this: 1, 0, n, reacted 1, 1, p, plus 0, 1, minus 1, e, plus energy. A similar process happens in the nucleus in beta decay. Electron is emitted from the nucleus as a beta particle. This leaves the nucleus with the same number of nucleons as before, but with one extra proton and one fewer neutrons. In beta decay, a daughter nuclide is formed with the proton number increased by 1, but with the same nucleon number. For example, strontium 90, the parent nuclide, may decay with the emission of a beta particle to form a daughter nuclide, yttrium 90, as in the case of alpha emission. Energy is evolved and the decay is represented by the nuclear equation 9030 SR reacted 9039 Y plus 0 minus 1 E plus energy. Now we get to the third one, and that's what we call radiation. Well, radiation is part of the electromagnetic spectrum with wavelengths between 10's power raised to minus 11 m and 10's power raised to minus 13 m. Since radiation has no charge, its ionizing power is much less than that of either alpha particles or beta particles. Radiation penetrates almost unlimited thickness of air, several meters of concrete or several centimeters of lead. Let me reiterate, it's very important. Since radiation has no charge, its ionizing power is much less than that of either alpha particles or beta particles. Radiation penetrates almost unlimited thickness of air, several meters of concrete, or several centimeters of lead. So it passes through and goes on. That's what we have radiation.